And good afternoon, everybody. Welcome to today's webinar presentation, How Do I Maintain My Burner System? My name is AJ Pispor. I am the Business Development Manager for Combustion and Advanced Controls at Lesman Instrument Company. I've been with Lesman for almost 10 years now. Prior to me joining Lesman, I was with our manufacturing partner, Honeywell Maxon, for about 10 years, and I did a brief stint with another specialty chemicals company. So I've been working in and around combustion for a little over 20 years now. Before we get into the presentation, I did want to let you know, for those that are attending live, if you did have any questions, in the GoToWebinar app on the sidebar, there is a questions area. You can go ahead and put your questions in that chat area or into the chat as well. I'll be going through and monitoring those, but I will allot for some time at the end of the presentation if you guys do have any questions. If you are watching a recording of this and you're not attending live, but you do have a question, you are also able to submit that to us through our website, and that will get filtered to me. But I also have my email address right here on the screen. It's just ajp@lesman.com, and I'd be happy to help you out. So before we get started into the meat and potatoes of our conversation today, I did want to just, lay out a couple of just ground rules, but also just, things that you guys need to keep in mind when we're approaching our combustion systems. Obviously, everything we want to do is got to be just safety first, right? These combustion systems, there's a lot of potential for energy with the just the fact that we're burning fuels, and we want to do that in a very safe manner. So we always want to just have a safety mindset associated with this, right? So if we're going to be going through and getting into any kind of equipment, we want to make sure that we're adhering to lockout, tagout, or whatever kind of safety protocols that you guys have at your respective sites. Also, you guys should, if you guys are either, working with end users where you're working with the equipment directly, or if you are with a service technician where you may be going into different facilities, you should really know your code, right? And for the combustion applications that I get involved in, there's really three main different code guidelines: NFPA 85, which covers boilers, and NFPA 86 is for ovens, furnaces, and dryers, and then NFPA 87 is for fluid heaters. I highlighted 86. That's the one that we mostly get involved in, at least at Lesman. And I reference NFPA 86 code a couple of times here during the presentation. So I always go back to that. You may have a different code requirement or a different set of guidelines that you follow. That's perfectly fine, just as long as you know which code and which set of guidelines that you need to adhere to. And also, we just want you to know your limits, right? I do appreciate everybody taking the time to join us this afternoon, as just to learn a little bit more and kind of empower yourself. But we don't want to go too far, too fast with this. So if you feel like you are kind of getting into an area that you're not 100% comfortable with, we definitely recommend, if you're an end user, bringing in, some service technicians. We have a wide network of service technicians that cover our sales territory. And if you're outside of our sales territory, I'm sure you can either reach out to your local distributor or to Lesman, and we can help try to figure out who might be a qualified service technician that would handle your area until you can develop that knowledge and that skill set to do the work yourself. And then obviously for service technicians, if you primarily work on boilers and you get called in to work on a furnace, there are really two different types of applications, although they all have a lot in common. Just the way that they're done, the approach to safety is a little bit different. So I just want to make sure that until you are familiarize yourself with those applications, maybe you might want to bring in somebody else on your team, or maybe from an outside service company that is more familiar with that particular application before you get too involved. So, we talk about how do I maintain my system. right, there's also there's a set of guidelines in NFPA 86. Now, NFPA 86, as I previously mentioned, is the guideline that covers ovens, furnaces, and dryers. And there's different sections within NFPA 86, and I did want to cite a couple of different callouts in NFPA section 7.4 regarding inspection, maintenance, and testing. Right, so 7.4.1, safety devices shall be maintained in accordance with the manufacturer's instructions. Right, this seems to make sense. Right, if if you've got like a Honeywell flame scanner and they've got a certain set of guidelines for using that and installing it and wiring it, you want to make sure that you're adhering that. And if they've got a maintenance schedule, that you adhere to that maintenance schedule as well. 7.4.2 says it shall be the responsibility of the furnace manufacturer to provide instructions for inspection, testing, and maintenance. So that may or may not be the case, right? If you inherited a very old furnace, some of that might be outdated. So you might have to just kind of start piecing some of that together based on experiential knowledge of that furnace, or start organizing some of the literature for the components that are installed on that furnace. 7.4.3 says it shall be the responsibility of the user to establish, schedule, and enforce the frequency and extent of the inspection, testing, and maintenance program, as well as the corrective action to be taken, right? So this is just asking the users of the equipment, right, the end users themselves, to have their kind of a proactive type of a maintenance routine that you have scheduled outages for. A lot of the code cites that certain components need to be tested on an annual basis. So I would hope that everybody here is at least doing some kind of an annual shutdown and inspection. And then depending upon your application and the demands of your process equipment, maybe you might have more frequent, scheduled downs and inspection times, which is also very good. 7.4.4, all safety interlocks shall be tested for function at least annually. Again, it's the annual requirement, right? These safety interlocks are in place to make sure that they protect the system from any kind of excursion from normal operation. And we just want to make sure that nothing's been jumpered or the device hasn't failed, so that it will shut down when required. 7.4.5, the set point of temperature, pressure, or flow devices used as safety interlock shall be verified at least annually. Again, some of these devices, like a high temperature limit, you've got adjustment points on there, right? There's a temperature set point that you program into there. So is that, is the device tripping off at that set point, and is it responding the way that it should? Because you could go for many years without actually tripping the high temperature limit. But you do want to make sure, though, that if you do have an occurrence, right, and that does the burner does run away, or the temperature does start to deviate upward, that device is going to be working, and they do want to test that annually. And safety device testing shall be documented annually as well, on an annual basis, right? So having some kind of checklist of sorts that you can go through and file and show that, hey, during this previous outage, we went through and tested these devices in this way, right? Just coming up with that game plan. So the first thing, once we shut our burner system down and everything's cooled down, is we want to just take a look at the burner itself and just do an inspection, right? Having the burner shut down and the chamber cooled down gives you the unique opportunity to be able to look at the burner from the other side, right? Where most of the time when we have a forced air burner, we've got that externally mounted part where the air are coming in. You might have a little sight port on the back. That's where your flame detector and spark igniter are coming into. That's relatively easy to see and get access to. But the business end of the burner, where the flame's coming out, obviously you can't do that while the burner's running. So you need to have this opportunity while the system's down to go in there and take a look. You want to just take a look and document the state of the burner, and just kind of make any notes to yourself, or taking pictures. That's the great thing about the digital cameras and cell phones, is that you can snap pictures, file them away, and then you can kind of compare them between your visits or between your outages to see, is the burner looking like it was last time, or is it starting to, to kind of veer off course and start to show signs of wear. So one of the things that you look for is, any kind of buildup or scale, right? With a lot of the hydrocarbon fuels that are used, right? Natural gas or propane. If you are burning in such a way that is maybe got excess fuel, or you don't have enough combustion air, it could cause quite a bit of soot buildup, and that could build up on the inside of the burner. It could start plugging gas ports. It could also coat your flame rod, spark igniters, anything else that might be in the path of that flame. So just want to, you can go in there and clean some of that off, and then at some point, if there's any kind of looks like more permanent damage, like what I show here in this picture. This is an example of this looks like a Maxon oven pack burner, where customer noticed that the discharge sleeve, right? This is this cylinder. It's not supposed to be that shape. It's supposed to be nice and round. But they noticed that was starting to create like a little bit of a different kind of a shape, almost kind of like a hexagon, or maybe kind of flowering out a little bit. So it's, the purpose of that discharge sleeve is just to protect the flame from cross velocity and help develop the flame. So, definitely has changed its shape, but its function is still there. So, when we told the customer about this, we recommended that they go through and order a replacement and get that one installed. They could run in the meantime, but the next time that they had an outage, that they want to make a plan to go through and change that. In this particular burner, you can see a flame rod protruding through the middle of it, and that looks to be okay. The gas nozzle and the mixing cone do have it does show significant buildup on there, but looking at that some of that can maybe just be cleaned off by like a wire brush. Making sure that those gas ports aren't getting blocked with any kind of debris. And as long as obviously these burners are nice and shiny when you first get them from the factory, and then of course after some operation they will start to show some buildup, start to show some oxidation and signs of wear. But as long as the general shape of the components of the internals are still intact, and nothing else looks to be deformed and warped, then you should be okay to operate as is. But again, you always want to get in there and see what's going on for yourself. For those of you that have like induct line burners, I don't have a picture example of this, but they're the burners that have like these mixing plates that are in a V shape, where you've got a gas manifold in the middle. A lot of times you'll see those they've got little holes in the mixing plates that allow for air to mix with the fuel in a staged manner. It's okay if you've got a little bit of like wear and tear and a couple little cracks here and there, but you don't want to see like a big new opening, right? Or parts of that mixing plate missing. So again, just on a somewhat at a minimum on an annual basis, and ideally like maybe 2 times a year or maybe 3 times a year, you can get in there and just kind of document that a lot of those components can be replaced, right? And if you do have any questions about that, you can get a hold of us or your distributor of your burner products to see what would be available as far as replacement components. There's a certain number of burners that have internal linkage, right? So these are package burners that have air fuel linkage on the inside of them. So for those particular burners, you do want to make sure that linkage is intact. You can unhook the control motor, and you can just, as long as you can freely move it by hand, where it doesn't get bound up or lock up at a certain point, then you should be okay to go. A lot of times these are tied to external position switches. You also want to make sure that as you're bringing it from low fire to high fire and back again, is it making contact with those position switches? There's a little offset toggle on there. You may need to adjust that, right? Mechanical linkage in general has a tendency for hysteresis, where you get some slop over time. And Some of that can be adjusted out, right? There's adjustments that you can make to linkage arms and set screws that you can kind of tighten everything back up again. Otherwise, so some of these linkage kits, like from Maxon, for example, for these oven pack or tubo flame burners, they sell replacement linkage kits, where you can just replace all the linkage and the air and gas butterfly valves if you deem that it's not, it doesn't look like it's working properly. One of the common things about these package burners, right? You do have pressurized air and fuel, and then there these op shafts go through the casting, and there's a number of O-rings and gaskets that are used to try to keep all the gas and air inside the burner. So you want to check those spots and make sure that you're not getting any kind of leaks coming out of there as well. So once you've gone through and done your visual inspection and you've done your testing, and it's time for you to start your burner back up again, you may want to just do a verification just to make sure that that burner is receiving the proper air-fuel ratio, right? So all of the different burners have documentation that show for this particular model and this particular size of that model, there's a requirement for airflow and fuel flow. Sometimes they'll just give you the flow rates directly, and then, but most of the time you're measuring via a manometer, you're measuring differential pressure across the test connection ports in the chamber, and that's how you would verify the air-fuel ratio. So if you've got that documentation and you've got the time and ability, certainly do encourage you making sure that the burner is operating at that proper air-fuel ratio. Right, that other example that I showed with that Maxon oven pack, I think that when we started talking to the customer and figuring out what was going on, they were either exceeding the temperature limits of the burner, or that burner was running out of ratio where it was burning a little bit richer, so they get a higher temperature flame acting on that discharge lead, causing that deformation that you saw in the picture. So operating the proper air-fuel ratio, not only does it help you out from a fuel efficiency standpoint and thermal transfer standpoint, but it also just makes sure that you're keeping the burner components cool. You're just prolonging the life of the burner. And depending upon your application, you may have to make seasonal adjustments, right? So this is, very common where we're located in the Midwest. If you're pulling in outside air, you've got, in the summer it could be 80, 90 degrees, but then in the winter it could be in the single digits, right? And that difference in density of the air has a very big difference on the operation of the burner and the air-fuel ratio on that burner. So depending upon, again, your application, what you guys are doing, where you're located, you may require some additional adjustments on your air-fuel ratio. Again, if you have any questions about what those are, you can contact the burner provider or your distributor or the manufacturer of the equipment, and they can let you know better about what kind of air-fuel ratio that would be optimal for your application. Now, one of the critical safety components on any combustion system are the shutoff valves, right, or safety shutoff valves. These are the valves. You'll have two of them in series with each other that will slam shut at the first detection of an upset condition, and this is the device that's preventing the gas coming in from the street to get into your burner system until it's time for you to introduce that fuel, right? So they serve a very critical purpose. So I wanted to spend a little bit extra time with you guys just to hammer this home about the importance of shutoff valve maintenance, and also kind of walk through what a typical seat leakage test looks like, right? So one of the tests that you can do first is a cycle testing, right? This is just the basic functionality of the valves, right? These valves are two position. You energize them and then you de-energize them, and then depending upon whether you have a blocking valve, it's going to be normally closed, meaning that in the de-energized state, it'll be closed, and then you've got your vent valves that are normally open. Again, opposite in that when they're de-energized, the valve's going to be open. So in the energized state, the blocking valves go open, your vent valves go closed. Each of the blocking valves should have position switches or maybe proof of closure switches, depending upon the model of valve that you have. You also want to verify these, right? Like and when you energize your valve to go open, am I seeing my open switch contacts? And then same for when the valve's closed and de-energized, am I getting that valve closed or proof of closure switch being made in that position? You also will have visual indicators on a lot of these valves. I've seen it before where the visual indicator falls off and then you don't know whether it's open or closed. So you certainly, that's one of the code requirements, is to make sure that if you've got a shutoff valve that's over a certain capacity, I think about 400,000 or maybe 150,000 BTUs, you need to have visual indication on those. So you just want to make sure that as you're doing your cycle testing, do you see that visual indicator? Is it clearly marked? Does the operator understand what that visual indication represents? You also want to make sure during the cycle testing, right, that your shutoff valves will close in less than a second. And this is called out in NFPA 86, that the safety shutoff valves shall close in 1 second or less upon being de-energized, right? And they want the valves to go closed incredibly quickly. I think there is a caveat in there saying that they'll allow for a longer stroke time, but as long as it's maybe 5 seconds from the point of flame detector, so maybe you'll lose a little bit of a time on your flame failure response. Maybe you have to go with a shorter flame failure response time to allow for more time for the valves to go closed. But most of your Maxon valves, Honeywell valves, chrome Schroeder valves, the ones that you commonly find, ASCOs that are commonly used in combustion applications, all will close in less than a second. So just want to make sure if the valve's closing slow for whatever reason, then you'll want to inspect that or take a look into that and see why that might be the case. A lot of times when I've seen that happen, it's because you've got buildup on the seat, the disc inside of there. So you may need to get in there and do some kind of cleaning action, or maybe with the pneumatic valve, there's something going on with that, with the solenoid that releases the air from the cylinder that holds the valve in the open position. Leak testing, again, we'll go through this in a little bit more detail in the next couple slides. This is just verifying that you've done your cycle testing. They'll open when they're supposed to, close when they're supposed to, but when they're in the closed position, again, these valves are designed to prevent gas from getting into your system. You want to make sure that they are doing that job, because if they're allowing a significant amount of gas to go by, then that creates a very unsafe condition. So we want to make sure that these are working properly. And then that could be either to the Anticlassic seat leakage standards, or you may have a bubble tight requirement. And I'll get into that here in the next slide. So Anticlassic seat leakage is it's the most common classification required for industrial gas shutoff valves, and it's a standard that does allow for a certain, it does have an allowable seat leakage rate, as you can see here on this slide, based on the port diameter or the size of the valve body, right? And as you see here, as you go up in port diameter, there's an allowable number of bubbles per minute. And by bubbles per minute, this is in a reference to the test apparatus that is called out in NFPA 86. And those of you that have performed the leakage test, you probably know what I'm talking about, but for those who don't, it's a very simple apparatus, and there's actually within the code, it calls out the specific size of tubing and everything else that you need to be using and how that tubing is cut. And you submerge that tube into a bucket of water. I think you insert it about 1 inch below the surface, and then the other end of that tube is connected to the test connection port on the downstream side of the valve that you're testing. And with that valve de-energized and the downstream side of the valve isolated with the equipment isolation valve, you apply pressure to the upstream side of the valve, and if there's any gas leaking that's occurring, then it's going to go through the tube and it'll come out the bucket as a bubble. And so what you're doing is during that test, you're counting how many bubbles per minute are coming out of this valve. If you're trying to meet the Anticlassic seat leakage rates, then you'd follow this table. So let's say I have a 4-inch valve. If I am at 11 bubbles per minute or lower, then I am meeting the ANSI Class 6 seat leakage standards. If your site or the authority having jurisdiction determines that these valves must be bubble tight, that means that you are allowed 0 bubbles per minute. So any kind of leakage coming out of there would require, it would fail the seat leakage test and would require you to replace that valve. So I have a simple line diagram of a common fuel train. This red line right here is consider that as the pressurized fuel coming into the fuel train, and all of these components, if they are darkened, that means that they are in their closed or de-energized state. So I actually have my equipment isolation valve here that's in the closed state. And you want to do a visual inspection first of your valves just to make sure that everything's closed. And just an FYI for those, this is a drip leg and strainer down here on the bottom right, bottom left rather. Up on the top part, I've got my pilot line, and down below that, I've got my main gas line. So after you go through that visual inspection, then what you want to do is you want to first start testing on the main line. You want to test this upstream valve first. So on the downstream side of the first shutoff valve, there should be a test connection port. All the valve manufacturers build these into the ports. If not, then you would probably need to have some kind of a test port installed downstream of the valve. But most all of them do have this test connection port available. Might be a little 1/4-inch plug, like a Maxent valve has a 1/4-inch plug. And then you install your hose and your bucket of water. If you do have a vent valve in it, if you have what's called a block and bleed, where you have your 2 normally closed blocking valves and then a vent valve, you need to isolate this area downstream of the first valve, so you need to energize that vent valve. So you got to jumper that on, or got some customers that do this on a regular basis. They actually have a local switch that allows them to energize the vent valve for this valve proving test. So once you get that installed, then the next step would be to open up this valve and put an isolation valve. So this will bring my gas through the main gas regulator all the way up to the upstream part of this valve, which is still de-energized and closed. Right, and then the guidelines or the recommendations are to test for 2 minutes per inch of pipe diameter. Okay, so let's say if we have again that example of a 4-inch line. So if I have a 4-inch line, then I need to test for 8 minutes. So for 8 minutes with the pressure on the upstream side of this valve, we're going to be going through and counting the bubbles per minute, if there are any bubbles. And you do want to wait for that entire duration, because even though you may not get some right away throughout the entire duration, you just want to make sure that there's nothing building up and then coming out a little bit later. When you do have a valve that leaks, a lot of times you'll know it right away, right? You'll get that on there, and as soon as you open up the little test connection port or introduce the gas, you'll start, it'll look like a pretty like a fountain or maybe like a little like a motorboat or something like that in that bucket, where you're just spewing gas out of there, and you know for sure that either the valve is leaking or something's wrong with your test rig. But anyways, just wait that whole duration, and if you're under your allowable seat leakage rate or you're bubble tight, then you're good to go, and then you can proceed to test the next valve. So then you want to, of course, remove the test apparatus and install the pipe plug, and then you're going to move that down to the next valve, the downstream valve. Now, the tricky thing about testing this downstream valve is that you need to energize your upstream valve while keeping your downstream valve de-energized, right? Like on normal combustion applications, both of these valves are powered off of the same terminal. So you'll need to either manually unhook the power on the second valve just to keep it in its de-energized state, or you need to come up with a wiring schematic or a way to go through and just only power the first valve while leaving the second valve de-energized for this testing duration. And again, just like the previous one, you want to do it for 2 minutes per inch of pipe diameter. Once you're done, you can go through and remove your test port, and then you can reinstall the pipe plug, and then, before you're ready to go for normal operation again, you'll want to open up your downstream isolation valves. You also may want to do the same thing on your pilot line as well, in the same steps, but just taking it up to the pilot line, because again, it's important that you also test your pilot valves as well. So, so that's basically it. Just make sure that you do it in that order. You're adhering to whatever guidelines that you guys have in place as far as the allowable seat leakage rates. And then this is to be performed on an annual basis. It's actually written into the NFPA 86 code. So, so you want to definitely make sure that you've got a plan in place for going through and doing this at least once a year. So now switching gears, I want to talk about some of the other components that you find in your combustion systems that you may want to look at and maintain. So the first one being pressure switches, right? We've got there's at least 3, possibly more in any kind of combustion application. You'll have some kind of either combustion air or maybe a duct air pressure switch, and a low gas and a high gas pressure switch. A lot of times you can test these in line, right, where you don't have to physically remove the switch. You can, for your combustion air, that's probably the easiest one to test out, because all you need to do is really just turn the combustion air fan on and then off again. And if the switch makes, then breaks as that moves, then you should be in good position. For the low gas pressure switch, it's pretty easy as well, because you can close the upstream valve like we did at the beginning of the leakage test, but then you can take the upstream plug out of your shutoff valve or somewhere else and just relieve the pressure that might be built up in there. And then that low gas pressure switch is normally open. So with pressure in the line, it's gonna make, but then as you lose pressure and you relieve the pressure from there, it will break. So so that's a pretty easy one to test out. So you can close the upstream valve, bleed out the trapped gas, and then if it trips, then you can just re-energize, open up that isolation valve again, and then if the switch makes, that you know your low gas pressure switch is good. The high gas pressure switch, you can do something similar, but it's not 100% that it will trip, because what you want to do is you want to try to maintain pressure in that area where the high gas pressure switch is installed, which is downstream of your shutoff valves. So in order to do that, you have to force the valves open, but you don't want to force that gas to go into the chamber. You got to close that equipment isolation valve. And even with the shutoff valves open and your equipment isolation valve closed, that deadhead of pressure right there at the location of your combustion air switch, then it could be not enough pressure to trip that gas pressure switch. So you may need to either lower the adjustment range to where it breaks, or you may have to remove it completely from the line and do an offline test rig. And that's actually somewhat recommended if you're looking for just the most accurate method of pressure testing, right? Because you can get like a little hand pump that you would put pressure inside of a small section of pipe, and you could also have a gauge or a manometer connection, so that you've got a reference to the pressure that's in there, and then you can inflate that that pipe or pressurize it rather to the point where you want that switch to be made, and then you can dial that in very precisely with that offline test rig. So it's something to consider if you've got a lot of switches and it's critical for you to have those set very precisely. You probably are already doing something like this. Of course, with the pressure switches, you want to verify that there's no leakage on the either at the pipe connection where that gas is coming into the switch or inside of the switch itself. Right? The gas should deadhead right there. There shouldn't be any kind of gas flow, in or around the switch. So the next one is going to be air-fuel ratio maintenance, right? So we talked about this previously on the package burners, right? That may have that mechanical linkage on the inside of the burner, but a lot of forced air burners have the air-fuel ratio outside, right? You may have a mechanical linkage where you've got a single actuator connected mechanically to an air and a gas valve, or you could have something like parallel positioning or electronic linkage where you've got multiple actuators direct coupled to valve bodies, and then they're electronically communicating their positions back and forth so that they know that they can that they travel together. So with either of these, you just want to verify that actuator to valve linkage is still sound, right? That connection, whether it's the direct connection of the electronic linkage or the mechanical connection, which may be a number of different connecting rods and toggles to make that connection. Make sure it's still sound. There's no slipping. You're able to fully travel between low fire and high fire without getting, hung up on anything. And those that have position switches tied to them are those position switches, pulling in at the right positions, right? So during your pre-ignition light-off sequence, you need to verify high fire position for purge and low fire position for light off. And you just want to make sure that those switches are pulling in at the right moment. For the mechanical linkage option, you want to make sure that you want to check your hardware. Does the hardware or the linkage need to be adjusted at all, right? If it's not going fully open or fully closed and you want it to, you may need to make a linkage adjustment, or if it's getting held up, there might be some kind of an adjustment that you can do on that to make it a little bit more reliable. Electronic linkage, you don't have the mechanical linkage, right? Because it's direct coupled to valve bodies, but you do want to test out and make sure that that position feedback, which is critical on a parallel positioning system, is working as it should, right? Because you don't want to have a scenario where your air valve, as you're going from low fire to high fire, your air valve stops moving for whatever reason, but your gas valve keeps on going open further and further and further, creating a fuel-rich condition on your system. So you definitely want to make sure that they're, not only are you testing out the appropriate input signals, go to purge, go to light off, but you're also just making sure that the system as a whole is working the way that it should. And really, one of the easiest ways to do it is just to remove power from one of the actuators, right? So you got two actuators, an air and a gas. You could have more depending on the application that you have, but if you remove power from one of those actuators, how will the system respond, right? So if I disconnect my air valve, will my gas valve continue to move open, or will it stay at the last known position of that air valve? And also, will that action cause an alarm that will trip my burner system down? I hope that it would, but it's just something that you want to go through and be able to check, since a parallel position, in a way, even though it's not a safety valve on there, in a way it is a safety device, in that they need to both be working properly in order for you to maintain fuel flow into your system. We got combustion air blower maintenance, right? So for those applications that have forced air, we want to check and make sure that combustion air blower is properly working, right? Its job is to deliver a certain volume of air at a given pressure. That volume changes based on the firing rate of the burner, but the pressure should be relatively consistent. There might be a little bit of change here and there, but you do want to just make sure that it's still outputting, the same amount of pressure that it always has been, right? If it's not, then it could be a sign that maybe there's something going on with that impeller on the inside of the inside of the blower. Maybe it's maybe there's some build up, or something else might be going on in there, or maybe it might be a sign that maybe the motor operator, not rotating at full RPM for whatever reason. You also want to listen for it just to make sure it's not making any kind of unnatural noise. Like I think we've all, just know about rotating assets like this that, you get used to a certain sound that it makes as it turns on and as it's operating and as you throttle the motor up and down. But if there's any other kind of unnatural noise, like a screeching or a squealing, or even like a vibration, that could be a sign that, hey, something may not be right here. So, a lot of times when you are running your burner system, you got every other system fan on, it may be difficult to hear this. So that's why it's always nice to be able to isolate all that other noise and just focus on the combustion air blower so you can hear what's going on. And then, of course, common sense, right? If you've got a filter assembly like the one pictured has on the inlet side, you want to make sure that filter is being maintained, right? You've got a clear filter, and that's not getting buildup, because that could also prevent your from you getting full combustion air and maintaining an optimal air-fuel ratio. Next thing that you may want to take a look at during your planned outage and what to maintain would be your flame detector, right? So most common ones are going to be flame rods and UV scanners. For flame rods, they're pretty simple devices, right? It's just it's a ionization rod that gets inserted into the flame, and then current is sent through the flame rod, through the flame, and grounded out on the burner. There's really no like optimization of that flame rod. Really, the main thing that you can do is you can inspect it and clean it if there's any kind of buildup on there, and put it back in there. It is recommended that you replace it on an annual basis. Just like any kind of electrical component, it just over time would just start wearing out and not being as effective. But you guys are ultimately the experts on your individual systems. If you know that your flame rods, everything is optimal and the flame rods work for years, then that's fantastic. But if you start to see like a weak flame signature, or you've got some other kind of nuisance shutdowns, flame rod is a pretty inexpensive thing to replace in an effort to try to address those issues. UV scanners, again, these are looking for a clean line of sight at the flame. If you've got dirt or debris building up on that scanner lens, that could prevent the UV scanner from detecting that flame. So you'll want to get in there and just clean that scanner lens. Every application is a little different. Some of these are nice, clean. Other ones, there's quite a bit of, it gets quite dusty in some of these environments. So if you've got a particular application, or your environment is such that scanner lens could, and it will get plugged up with dust or debris, you may want to consider installing purge air, right? So just a small volume of pressurized air that would go into the sight tube that would prevent anything from the combustion chamber trying to get back up into the sight pipe and getting onto the lens of the scanner. A lot of times, if you don't have instrument air available, a lot of times people will take a little tap off of the combustion air blower upstream of the air control valve, where it's always going to be under higher pressure, and then they just tee that into the scanner line. So it can just be as simple as that. UV scanners as well. You may want to do a functional offline test. So you can do it actually online as well if you're able to remove the scanner but keep it wired into the flame safeguard. You can either get a UV lamp or some kind of a torch, or like a butane lighter, hold it up to the eye of the lens just to make sure that the flame safeguard is detecting that. And then when you have one of the more enhanced scanners, like the self-check UV scanners that have the mechanical shutters, right? It's basically the same as the traditional scanner, but it's got a shutter mechanism in there. You just want to make sure that shutter mechanism is functioning properly. So So there's a shutter terminal on like the Honeywell version where when that terminal is energized, the shutter goes in front of the photo eye and stops the photo eye from detecting the flame. And then once it de-energizes, the shutter moves away. You just want to make sure that that shutter is able to freely move as it's energized. And then as far as temperature sensors are concerned, you know, kind of like a flame rod, there's really not much to these. The periodic just inspection and cleaning of them may be sufficient enough, but over time these can start to get temperature drift where if you've got a combustion application where you're normally operating around 1200 degrees and your thermocouple is measuring around 1200 degrees, but then you start to see the temperature start to change a little bit. If it's the control thermocouple, your burner is going to start changing its output. So you want to make sure that your drift is not, especially on your temperature control, but also on your high temperature limit as well. You want to make sure that these are controlling in a repeatable manner, that they're, if you've got two of these thermocouples, right next to each other, they should be measuring roughly the same temperature. All right, so one of the big giveaways is that like a customer may have their high temperature limit sensor and their temperature controller sensor, within like a foot of each other, and then all of a sudden they start to see the high temperature limit sensor measuring quite a big different, quite a different temperature from the other one, and then that's kind of a sign saying, oh, I've got, one of these two may not be right. So that's why you may want to just replace them, or depending upon how many that you have there. I know some customers have a dry block calibrator, right? And for those of you who don't know what it is, it's essentially a box that you insert the probe of the temperature sensor into, and it's got a way of creating a small control temperature within there to reference against. So you can put your probe into there, and you can program in a set point of 500 degrees, and you can see how closely your temperature sensor is reading that 500 degrees. There are certain types of sensors that can be recalibrated that have some adjustments on there. Other ones would, like a traditional Type J, Type K thermocouple, would just be replaced at that point. Now, when you're coming out of an outage, or when you're going into an outage, one of the things that I mentioned earlier in the presentation is that you want to do some functional testing on all the sensors, or all the safety interlocks. And I always thought that when you're bringing your system offline or getting ready to bring it online are really the kind of the perfect times to go through and do some of this testing. So if I'm involved in a test and the system's been running for a while and they're getting ready to bring it down, one of the first things I want to test is that high temperature limit set point. I want to see, hey, am I able to just temporarily drive that burner up to that set point, or maybe I want to bring that set point down a little bit and then drive it up, because I want to make sure that the high temperature limit is working at the desired set point, and it shuts down at that desired set point. There's ways that you can go through and do it and fake it, but I like to try to do much of this testing, in the process under normal conditions, than trying to test everything offline. Obviously, you'll bring your burner system down. Obviously you'll need to have some time to allow the system to cool down, but before you bring everything all the way down, you can maybe just try doing a couple of relight attempts, but purposefully don't have the burner go all the way through the relight. You may want to test the individual components and trip your low gas pressure switch, high gas pressure switch, combustion air switch, or any of your other running interlocks during that run sequence, just to make sure it stops the run sequence from occurring and causes a lockout to trip the burner system down. And again, this will be different based on your application and the safeties that you have in there, but anything that you have that's designed to shut the burner system down, you want to try doing some kind of a test on it to make sure that it is indeed going to trip the burner system off. So the running interlocks are the ones that are running all the time, but there's also the pre-ignition interlocks, right? These are your proof of closure switch on the shutoff valves, and then your high fire, low fire position switches, right? Those all need to be made at certain points during the light off sequence. So one thing that I like to do is I like to disconnect some of these, like either the signal wires coming back from the devices or doing some other kind of a method to clip or prevent these signals from happening, just to see what happens on my system. And usually what will happen is that all of the flame safeguards have some kind of a time allotment for verifying these positions, and if they don't see them after a certain amount of time, then it will shut you down, and that would be a successful test. Right, the proof of closure switch may not even let you go through the light off sequence until that proof of closure switch is made. And again, depending upon your flame safeguard and the way that your system's designed, it may have a different reaction or behavior. But the main thing is that if you're not verifying these pre-ignition interlocks, they don't, you shouldn't be going through the light off sequence. And then my final slide here, best practices. Anytime that you are going through and doing testing, especially if you're doing testing where you're removing components and putting them back in, you always want to check for gas leaks, right? And this is just the soapy water test where you spray the outside of your connections down while the gas service is activated, right? A lot of times, like I walk into an area where the burners are burning, and there's a noticeable, natural gas smell, right? There's that mercaptan that's added to the natural gas to give it that odor. Those of you that have been around it enough know the smell all too well. Now, some of that might be normal, right? Because it just might be bad venting, where you got like a vent valve or something like that that's just tying back into the room. It really should be vented out to a safe location, but we don't always see that that's the case. But you definitely want to take that opportunity just to spray everything down and make sure that you're not getting any kind of new gas leaks forming. And that could be something that you can even do not during your regular down outage. You can do that when the system's running, and it may actually be preferred in many ways, right? Because while your system's running, you're getting all that gas flow going through the gas piping, and you can go through and spray all that down, not affect the operation of the burner. And detect for gas leaks at other places, especially downstream of your fuel train. Spark igniters, I didn't talk too much about spark igniters, but you do want to inspect and clean those, kind of like at the same kind of cadence as you would with your flame rods. If you're using flame rods, again, there could be some buildup on there. You definitely want to clean that off, and then just replace those on an annual basis. And I can't emphasize this enough, is that, we as a distributor, right, we want to try to, make sure that we're meeting your needs and stock a lot of those critical spares. But, a lot of times we just can't keep up with the demand, or maybe we're waiting from our vendor partners to deliver some of the stuff. So I always encourage our customers, especially if you got a critical process where you can't be down for an extended period of time, is that you really need to maintain some critical spares in-house, right? Like a spark igniter, that's something where if the spark igniter goes bad, it's a little bit of a showstopper, because you can't get the burner lit again unless you have that ignition source. Flame detectors, flame rod, or UV scanners, right? It's going to be very difficult, if not impossible, to try to fake that out if that device goes bad. These are relatively inexpensive components. There's also just any kind of motors or actuator or any other kind of electrical components, right? Electronics fail, right? They do. A lot of these combustion applications, they're in areas where there's a lot of ambient, heat. There's like high heat around there just because of, just because that's the process calls for it, or there's just, poor insulation where some of that heat is getting back onto the electrical components. So it's important that you have spares of those electrical components. And again, mainly like your critical spares, right? If you lose a motor on a combustion air blower, that's bad. A pressure switch, well, you don't prefer it, but if you need to get by with a pressure switch, you can get by without a pressure switch, but you can't get by without a control motor or a combustion air blower motor, right? So some of those you definitely want to keep those available. And again, just emphasizing is have a proactive maintenance plan instead of a reactive plan. We've dealt with a lot of different customers, and a lot of them are very diligent about having a proactive maintenance plan, and it just cuts down on the surprises, right? And then other ones just maybe not have the resources, and they just have to keep the system running and then deal with the issues as they come up, right? But again, sometimes that works out okay, where you're able to address it quickly. Other times it's a stopper, and now you're waiting on us or from the vendor partner for some assistance. Well, that is the end of my presentation. I do see in the chat, I must have lost audio at some point, so I apologize for that. And then I see Bart, you said any tips for ribbon burners. So I think I might have highlighted that for you, Bart, a little bit, in that those ribbon burners or line burners that you have. And again, just the periodic maintenance inspection on the inside of the duct, just to make sure that the mixing plates are whole. You don't have any large cracks that are forming big gashes in the mixing plates. You also don't have a lot of deformation on those mixing plates. A little bit is okay, but there's going to be a certain point where you have too much, where it's going to affect the quality of the combustion. And then also one of the main things about those ribbon burners or those line burners is those gas ports on the gas manifold. They've got a lot of small little holes on the inside of there, and those can easily get carbon built up on there. So if you're in there on a pretty regular basis, you can probably address those with like an aggressive brush action to clean that off. If it's been a while since you've gotten into there and they're kind of caked on there, you can drill them out, but you got to be very careful in how you drill those out, because you don't want to expand on the diameter of the hole. So you may want to get a big box of drills and figure out what's the exact drill size that we need that will allow us to open up the ports without, at least remove the buildup without creating a larger opening. And maybe even go like one drill size down from that just to be safe. And then Steve, you wrote, did you record this? Yes. So this session will be recorded. We are going to be posting it onto our, we have a trainings page on our website that you can go to, and our marketing department will post it within a few days. So you can go back and recall this presentation. And Matt, I just saw your question come through. Yes, on that training page, I will have a copy of this presentation on there, so you can go through and download that from the website once that's uploaded. All right, and thank you for the comment, Steve. I see, so we got a couple of questions coming in. Is there anybody else out there that has any questions? So I'll give you some time to post on there. So Matt, yes, you do have a question on NFPA 86. So go ahead with your question. So NFPA 86, by the way, so I've got like a hard copy of NFPA 86. I've got the 2019. There is a 2023 edition. I think that I'm supposed to be, I'll probably get the digital versions from now on, because I don't really need these handheld or the hardback copies. Matt, you are muted. Let me see here if I can change it where.
Hello, how are you?
Hey Matt, I'm good.
Good. I had a question, I guess, on the NFPA 86. Didn't they remove the vent that is in between the two gas blocking valves on the main line?
Yes, you're correct. So they removed the requirement. So NFPA, it's a there's a number of people, and they update the document for years, and I think this might have been about 3 or 4 instances ago, so maybe like 12 years ago. It used to be in there, and it was specifically for burner systems over a certain capacity. They wanted to have that vent valve, but what they ended up discovering is that a lot of people were venting to an unsafe location. So, for example, somebody would take that vent valve instead of going up and out their roof and venting outside to a safe location. They said, "Oh, I've got this exhaust ductwork that's going out the roof anyways. I can cut down on the length of pipe and a hole through the roof if I just tie it back into there," not realizing that they just created a short circuit back to the burner system and created a new path for gases to collect inside of their chamber, so that's a big no-no. The other discovery that was made is, and I've had this happen a couple of times, is that vent valve, right? I think the rule of thumb for a vent valve is it's going to be half of the line size of the main gas line. So if you got a 4-inch, main gas line, you're going to have at least a 2-inch vent valve. You can actually have that vent valve fail, which is going to fail in the open position.
Correct.
But it will still allow for enough gas to flow through to the burner to maintain the flame safeguard and maintain control of the system. But at the same time, you're also venting a significant amount of gas up and out of the building. So it's just an incredible waste of fuel. And I had a customer that discovered this, not because they detected the vent valve or saw that the vent valve was in the wrong position or somebody detected the smell. They got their utility bill at the end of the month, and it was way higher than it normally was, and it forced them to go and to try to find what was going on. And they discovered that, oh yeah, our vent valve filled open, and we were just leaking gas out like for this whole month out of there without even knowing it. So NFPA has removed that requirement.
That's
now
what we've seen too, but some of the companies still have it in there when we inspect them too. I don't know if it's like good practice that we should recommend they remove it since it's been removed from NFPA D6, because most of them that have something in there is just a solenoid valve. That just
So NFPA, it's not making it a requirement, but it's also not forbidding it, right? So people still can use vent valves, and we still see them being used all the time. What NFPA and what the industry professionals are recommending, though, is that because the vent valve, the vent valve's got good intentions, right? Because the purpose of the vent valve is that, let's say you do have a gas leak on that upstream valve, right? Where's the gas going to go after it goes through that upstream valve? Is it going to try to go through the second downstream valve and get to the chamber, or is it going to take the path of least resistance and go out the vent? Of course, it's going to go out the vent. So by removing the vent valve from the equation, now that gas, let's say that same scenario, now that gas is leaking by the first valve, it's now going to build up pressure between the first valve and the second valve, and now you're going to have that line pressure acting on the second valve again. So people, will, so ultimately what people have been doing now, and I don't know if you've seen this on your end, Matt, is they've been using what's called valve proving. And I didn't really talk too much about this in this presentation, but it's an additional pressure switch that is installed.
Yeah, we've used that valve proving switch, the Crown Schroeder one, on some of our
Exactly.
sites.
Yeah, they've got that whole the tightness control. It's TCI or whatever that part number is to do that valve proving. So for those of you that are still on the call and are interested, the valve proving is a way to check for seat leakage integrity automatically by just cycling the valves individually open and closed to apply pressure between the shutoff valves to detect if the pressure increases or decreases during the test. Now, this does not replace the requirement to do the annual seat leakage test, but it is a way of determining, you know, do I have some kind of a seat leakage integrity issue between your testing periods. So I typically recommend valve-proofing.
Okay. You also mentioned, I guess, the leakage test, the annual leakage test. I know that on the gas train, the main gas train, but you also said for the pilot line. Was that a true statement that you said there? Sorry.
So let me take a look here.
Typically on our pilot line there, it's just 2 solenoid valves, so there's no real way to test in between that they're actually getting 100%.
Yeah. So if you do not have, let me see where it says it now. Again, I'm looking at the 2019 edition, not necessarily the most current one. There is a section in NFPA 86.8823, means for testing all fuel gas safety shutoff valves for valve seat leakage shall be installed. So to me, that incorporates both pilot and main.
You said that was 8823, so it was?
8823 in 2019. If you got the newer one, 2023, it may be something different. Do you have the current GOAT guideline there?
No, I got the 2019 edition.
Okay, on page 86-29.
Yeah, there are other acceptable piping arrangements. For example, pilot takeoff can also be downstream of the main pressure regulator. So
yeah, so there's, and again, it's a set of guidelines, right? It's not the letter of the law. Ultimately, your authority having jurisdiction, which is most likely the insurance provider, ultimately has the final say. If you're, but basically the way to interpret it is that if you're using solenoid valves that don't have the pressure tap on the valve body, that you need to install some kind of a T downstream, right? As a means.
What? Sorry, say that again.
If the solenoid valves that you're using on the pilot line don't have the pressure tap on the downstream port, then that just means that you would need to add some kind of a T assembly downstream with a test connection port on there as your means of testing.
Okay.
Yeah, it doesn't have to be.
You would do that same bubble test downstream.
Yeah. Yeah, the bubble test doesn't have to be performed through the valve body. You can do that in a T assembly downstream of the valve body as well.
So that should be incorporated in our design. Though if we use solenoids in the pilot line, there should be a leak testing point.
There should be a leak test.
And then after.
Yep.
Okay.
Yep. If it's not built in, you're using, what kind of solenoids are you using?
Just ask Red Hats.
Okay. You may want to double check. Sometimes they might be on the back side. Sometimes they're only just on one side. I know the Maxons only have them on one side, but I think like the Chrome Shredders have them on both sides. So you may want to just double check. But I know there are certain models of Red Hats that are like general purpose ones that are used in combustion applications, but also in other applications where they don't have it. But I think that the ASCO combustion specific valves do have that test connection port. So
I will look into what model number we use.
Okay, very good.
All right, appreciate it.
Yeah, thanks, Matt.
I think I had any other questions.
Okay, very good. And then Bart, would you recommend using a fuel gas analyzer for AirFuel ratio verification? So that is a good thing to do, especially on boiler applications, right? Where you are, where you're hooking that analyzer up to the exhaust stack, and the only airflow that's going through the burner system is coming through the burner. Right, on a drier application or an oven application where there's other sources of airflow, like process air or recirculation air that's in there, that's not really a great way for tuning the burner. Maybe tuning it out from an emissions standpoint, right? Like let's say you've got like an application where you're trying to achieve optimal NOx or CO production, but not from an air-fuel ratio standpoint where you're looking at O2, right? Because really that's what boiler technicians will do. They'll look at the oxygen percentage coming out of the exhaust stack, and they typically want to tune that air-fuel ratio control to try to maintain 3% oxygen or above. Any more than 3%, and it's you're not as thermally efficient, and then below 3%, you want to have that buffer just because you don't want to go too low, because you don't want to get to the point where where you've got 0% oxygen, and now you've got unburned fuel, going through your boiler system. So we do have, there are different analyzers that are available. If you contact us, I can give you some recommendations for a fuel gas analyzer if you don't already have one in mind. Well, I appreciate, again, everybody's time, and I appreciate the questions and the feedback. I always like doing these when we've got some good questions and good interaction with the group. And again, if you have any kind of questions for us, my email address is ajp@lesman.com. Please feel free to reach out to us directly, or you can find additional resources, including copies of this presentation and the recording of this on our website at lesman.com. And if you search for the training center, you'll find it there within a number of the other combustion webinars that we have done. And I do encourage you to go through our library of trainings that we have done in the past. I've done a number of them on why won't my burner light off? Why does my burner keep shutting down? I've done some beginner and advanced air-fuel ratio control topics on there. So I encourage you to go through and check some of those out as well, and certainly let us know if there's any kind of mission that you have that we can help you out with. Oh, Matt, I did see you had one more. After cleaning flame rod, ensure insertion length. Yes, yes, exactly right. Especially if you got the flame rod that's got the adjustable bushing on there. If you're going to pull that out, make sure you mark the porcelain, or that the insertion depth on it before you put it in. Thanks for sharing that. But again, appreciate everybody's time this afternoon, and thank you for joining.